Hello viewers, I'm Kausalya. Today we are going to solve problem number 4 and 5 related to RC series circuit. So here the problem is, in a RC series circuit, voltage across the combination is given by 40 sine 2000t plus pi by 4. So what do you mean by voltage across the combination? Which is nothing but your source voltage. You see, here we are having a resistor and here we are having a capacitor, right? And they are connected in series. So this is an RC series circuit. So in this case, you see voltage across the combination, that is the total voltage across this combination of R and C is given by this expression. So this total voltage is nothing but this is your source voltage V, right? And R is equal to 10 ohms. They had given the value of R. The current leads the voltage by pi by 3. So here the angle pi is also given. Find the value of C. Also find the expression for I. So here the thing is, first write down the given data. Okay. Source voltage is given, resistance and pi is given. So to find the value of C, we should know what is XC. Once XC is calculated, then it is easy to calculate C. So for that, here the thing is, we are taking the cos pi as the main factor here because we know pi, right? Therefore, cos pi is given by R by Z, right? So we know pi, we know the value of R. So we can easily calculate Z. Therefore, Z is given by R by cos pi, and here in the place of pi, just substitute pi by 3. Therefore, 10 divided by 1 by 2. So that gives the answer as 20 ohms, right? So in the case of RC series circuit, what is the expression for Z? Impedance Z square is given by R square plus XC square, right? R square plus XC square, we need to calculate XC square. So XC square is nothing but Z square minus R square. We know the value of Z, we know the value of R, right? So just directly substitute, and here the value of XC square is 300. Therefore, the value of XC is 17.32 ohms, right? So what is the formula for XC? It is nothing but 1 by 2 pi FC. In other words, we can write it as 1 by omega C. So here the value of C is nothing but 1 by, that is, I am moving this C here and bringing this 7.32 here. So 1 divided by 7.32 times of omega. So 1 divided by 17.32 into 2000. So when you solve, that gives the answer as 28.9 microfarad, right? And here we need to find the expression for I also. So expression for I is given by I is equal to Im into sine omega t plus some pi, right? So to calculate Im is given by Vm by Z. So how to calculate Vm? Again, just compare the given expression to the standard one. So here what is the value of Vm? The value of Vm is 40. So 40, the impedance is 20. So here the current is 2 amps. So how to write the expression for I? You see, the expression for I is given by I is equal to Im into sine of omega t plus some pi here, right? So just now we had calculated Im, right? We know the same omega will be there for I also. So plus pi. What is mean by pi? In the problem, you see, they had clearly mentioned as current leads the voltage by pi by 3 radians. That is, current leads, right? Therefore, here the value of pi is nothing but, you see, Im is to sine of omega t plus, that is already a pi, that is already an angle, you just write it as such, plus pi because the current is leading, therefore plus pi by 3, right? So this is our expression for I. And this problem gets over here. We will move with the problem number 5. A metal filament lamp rated at 750 watts 100 volt is to be connected in series with the capacitor across a 230 volt 60 Hz supply. calculate capacitance required and power factor, right? So here you see we are having a metal filament lamp, right? So whose power is 750 watts and voltage is 100 volt. It is connected in series with the capacitor. We need to find the capacitance and power factor. So here it's up to you. You can draw the diagram, or if you can solve by yourself, no need of this diagram also, right? So here the metal filament lamp, okay, it is said to be, that is, here you see it is just like a inductor, right? That is, to draw a metal filament lamp you have to use only this type of thing to draw a lamp here. So since but here the inductive property is comparatively less when compared to the resistive thing, therefore we are considering this entire metal filament lamp as a resistive load, right? So you see 750 watts, 100 volt, and voltage across the capacitor is VC, and the supply voltage is 230 volt, right? So first here they are given power, right? So power is 750 watts. So what is the formula for power? You can write power as I square R or V into I, right? So here V is given, we know the power, so we can easily calculate I. So we are using this formula. So power is given by, that is power across this lamp, therefore VR. So VR into I is 750, therefore I is nothing but 7.5 amps here, right? And the next thing is, as we all know, this voltage, okay, this V square is equal to VR square plus VC square. Therefore, so VC square is given by VR square minus, VC square is given by V square minus VR square. We know what is V, we know what is VR. So just substitute, and here the final answer for VC is 207.12 volt or 207 volt, right? And the next thing is, once we know VC, we can easily calculate XC, because what is the formula for VC? It is I into XC. Therefore, XC is given by VC by I here. Therefore, what is VC? It is 207, and what is I? I is 7.5. You see, we had calculated already. So when you substitute, the value of XC is calculated as 27.6 ohms. So from XC we can easily calculate C, right? So XC is 1 by 2 pi FC, and C is given by, just we have to interchange these two things. We have to move C here and bring 27.6 here. So once you substitute the values, you see the value of capacitance is given by 96.1 microfarad. Right, and the next thing is to calculate the power factor. So first the power factor is given by the formula cos pi is equal to R by Z. Right, so we need to calculate R, we need to calculate Z. That's it. So how to calculate Z? You see V is given by I into Z. So Z is nothing but V by I. V is given in the problem and I we have calculated. So just substitute. So here the answer is 30.7 ohms. And the next thing is power is given, right? You see now we are using this formula to calculate R. So P is equal to I square R. Therefore R is given by P by I square. So which is equal to, just substitute the values, and here the answer is 13.33 ohms. So finally power factor cos pi is given by R by Z. So just substitute it here and the final answer is 0.434, right? Leading, because here it is a capacitor circuit, right? Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.